Yeah, I don't mind kicking it off here, guys. First couple minutes is just introductions anyway, so if you're a few minutes late, you're not gonna miss out on too much, you know.
Okay, go ahead. I guess go ahead and get started, Jeff.
All right. So I want to thank everyone for coming and attending this webinar here today. My name's Jeff Greim. I'm the sales manager here at Cyvl.ai. Joined here with Shawn Strange from First Group. Shawn, if you want to give a little bit of a self-introduction about who you are, where you're from.
Yeah, I am Shawn Strange, a professional engineer with First Group Engineering, also co-owner of First Group Engineering. We've been doing asset management now at First Group for about 8 years, 9 years now, and before that, I did asset management through other firms as well. We started using GIS, start to catalog roadway or historic roadway ratings, as well as get in and add other bits of information through different types of databases to create the asset management plans that was kind of slow at first until community crossings got started. And that's what got us our big break in moving forward with getting a lot of these asset management plans going with the state of Indiana and working with LTAP specifically out of Purdue University. So, and my, I won't call him assistant, Grant Barker is our other engineer who I've kind of let take the reins of doing a lot more of the technical stuff now, especially with regards to the new equipment that we're using to speed up the process and make it way more comprehensive as far as data collection goes. So, Grant, do you want to give a quick 2-second blurb?
Yeah, Shawn said it pretty good. I'm the one, I'm collecting it. I'm in the car, doing it. I'm doing the GIS stuff for First Group as well.
Yeah. So while a lot of this stuff is pretty straightforward, we do get into the weeds on other items, but the methods and means that Jeff's going to start talking about today is actually pretty easy to get started. So I guess I'll run the reins over to you, Jeff.
Perfect. Emma, you want to do the next slide, please? All right, we did a little bit of introductions there. Great job there, Shawn. Yeah, a little bit about Cyvl. So we help engineering firms, governments map, assess, manage transportation infrastructure networks at a citywide scale. We got a pretty unique way of doing it. We've developed our own sensor stack, which I'll explain to you in a moment. This sensor stack allows you to automatically automate basically the whole world around you, pulling out whatever kind of deliverables you might want to have for the projects at hand. We're taking a very labor-intensive manual assessments, and we're making them a thing of the past by simply driving down the street, normal driving speeds, collecting all the data that you might need for a particular project. And what you see here is the sensor stack that we have developed ourselves. It mounts very simply to the roof rack of a vehicle. At the very top of the sensor stack, that's an RTK GPS unit. That allows us to have very highly accurate latitude, longitude measurements of where assets are located. So if we say that a street sign is at X latitude, Y longitude, that RTK GPS allows us to get within a 3-foot accuracy statement of those things, usually within a foot, once we do further corrections with our mobile LiDAR unit. Below that RTK GPS is a mobile LiDAR that's shooting up about 4 million points of light every second in every single direction. It has very highly accurate readings within 75 feet, 3 centimeter accuracy readings within 75 feet. So if we say that a telephone pole is 35 feet tall, that statement's within 3 centimeters of being correct. It's not quite survey grade, but we call it engineering grade. For the vast majority of projects we're working with our engineering partners on, that's good enough for the projects that they have at hand. You wouldn't want to do any kind of like bridge height measurements with it, but perfectly okay for saying, how long something is, how tall most assets are, like a tree, and so on and so forth. Then we also have forward-facing, rear-facing cameras. And then on top of that, we mount a 360 camera, so you get those great 360 views of the whole world around you. And these are the typical deliverables that we're providing for our engineering partners. Standard pavement scores, whether that's going to be PCI based or Paiser based. We have a really great distress detail report. I'll go into more detail on that as well. That can be loaded into systems like a Street Saver or Cartograph to give you your own pavement scores based on just those distress details. Pavement markings and stripings, another very common one. And then really any other right-of-way assets like your sign inventorying, guardrails, manhole covers, roadside trees. Really, it's a very extensive list, and we'll be covering that shortly as well. And at a very wide basis is the number one product. It's going to be giving scores for your pavement. So in this slide here, you're looking at a Paiser score, 1 to 10. And then the color combinations of what would be a good road or a bad road. This right here, very impressive stuff, but what really makes this impressive is the interpretability of these scores. So if we go to the next slide, please. So when we say that a roadway or a section of a roadway is a 7, it's not a black box just saying, hey, this roadway is a 7 because we say it's a 7. Instead of that, we were able to provide you with a distress detail report, which you can kind of see on the roadway here. It's every single roadway distress, 3-dimensional, 2-dimensional distresses, and we are able to map them, say where they're located, the type of distress that it is, give a severity rating of the distress, good, fair, poor, and then measure the distress itself, being able to say that it's taking up this much area, it's this length, or there's this many of them. And you can then take those scores and then interpret those scoring back to what we're giving to the roadway for a segment as well. So it's not just it's a 7 because we say it's a 7 because of all of these reasons of why it's a 7. And what really kind of makes us special here, guys, and separates us from a lot of the other automated pavement systems that are in the market today, is the fact that we're fusing together mobile LiDAR with imagery. A lot of the other pavement ones in the market today are just imagery alone. Imagery alone is really good at detecting the cracks, saying, hey, here's an alligator crack, here's a block crack, here's edge cracking. Where imagery alone really kind of struggles is those 3-dimensional defects. It's very, very difficult for AI to detect three-dimensional pavement defects from a 2-dimensional picture. So any of your rutting, your potholes, distortions, your bumps, your sags, a lot of those different defects are going to be missed from a 2-dimensional picture, but they're very easily picked up from our 3-dimensional mobile LiDAR. Also, by having 2 separate data sets that we're applying our AI to, it allows us to eliminate a lot of like the false positives that are out there. So if we just had imagery alone, that would be our only source of the truth. By having 2 separate types of data sets, we're able to compare and contrast the results. So for instance, AI is great, but AI is not perfect. Anytime there's like a shadow on the roadway, your AI is going to interpret that shadow as like a patch in the pavement, as a crack in the pavement, as a pothole in the pavement, because that's what it looks like on a picture. It's very hard to determine from a picture that different color distortion is just a shadow. So by having that mobile LiDAR come in and say, hey, no, Mr. Pavement AI, that's smooth pavement there. There's no crack there. There's no utility patch there. You've made a mistake. And that's the reason why that the system we've come up with here is so much closer to a boots on the ground analysis than the other systems in the market today. And just to kind of give you a great visualization of how mobile LiDAR is able to see these 3-dimensional defects in the pavement, here's a mobile LiDAR scan of a typical roadway. And you can see throughout this roadway, there's some bumps, there's some sags, there's some heaves. A lot of these defects are not going to be picked up from a traditional imagery alone. But by having this mobile LiDAR scan the roadway as well, we're able to pick up these defects that would have been missed. Sometimes these are even missed from a person driving down the street, especially like a lower severity rutting, things of that nature are going to be missed just from driving down the road. this mobile LiDAR is able to pick up these defects and get you highly accurate pavement scores because of that. So in addition to doing pavement scores, we can map and assess just about every other right-of-way asset. A very common one that is asked for is being able to do these lane markings and lane striping inventories for towns and cities. We can easily create these files for you that can be uploaded directly into your GIS formats. Oh, you skipped over one there. Okay, another, maybe our most common feature that we ask to get extracted as well is going to be a sign inventory. Normal driving speeds down the road, 35 miles an hour or less. We're able to detect every single one of the signs for your area. We can give you the METCD code for the sign, METC category for the sign, and a pretty exact location for those signs as well. So instead of just doing a pavement assessment, you can simultaneously be doing a sign inventory, simultaneously doing a lane and pavement marking striping, and really mapping any other right-of-way asset that you want for your project. And here's a great example of a lot of the different these are like the right-of-way point assets that we can do. You can see on the left-hand side of the screen, bus shelters, cabinets, traffic cameras, curb lines, fire hydrants, guardrails, jersey barriers, manhole covers. All these things we can easily do as long as it's easily to be seen from the vehicle as it's driving down the road. On our own platform, which you can have access to, you can view and see all these different features. You can click on one of the assets on the screen, a picture will come up with a point on it showing exactly where its location is as well. For here, clicked on a traffic cone on our platform. Here's the picture of the traffic cone, bounding box around the traffic cone. And the whole process is very, very simple. We ship our sensor to one of our partners. They drive around with the sensor on their vehicle. They upload that data to us. We then have our proprietary AI that goes into the data that they've collected, pulls out all the deliverables that they need for their particular projects. Then we post the deliverables on our website and they can download them directly from there, and we can format them so they're integrated easily into the software of their choosing. And really, this is what we're trying to eliminate the need for a lot of these manual assessments when you're going out there, you're mapping and you're measuring manually, and replacing it with simply driving around, much safer, more efficient, allowing our partners like First Group to do many more projects in a typical year than they typically were able to do before, while also maintaining a high level of quality for the projects that they're doing. And these are the main benefits of using our technology. And I'm sure Shawn will probably speak through a lot of these as well, but automatically inventory of many assets at the same time. All this data can be processed simultaneous. No additional staff is required. Very affordable, very scalable. And then onto that as well is once we've mapped a town for you, we can go back into that data. We could pull out deliverables later on as well. Or a couple of years from now, you're going to do another scan of your roadways. We can do a comparison study between the scan from 2 years ago to the scan today, and we could show you all the changes that might have happened within the environment during that 2-year plan. So maybe your town forgot that it's put up some different assets. We can point out those new assets that are there. We could point out some assets that were there 2 years ago that are no longer there, and make the town aware that these different assets are no longer available. Mr. Shawn, it's on you.
Okay, so at First Group Engineering, we're of course first a civil engineering firm. We've been around since the mid 80s. I think 84 was when we started technically. We work in a lot of transportation traffic engineering. We do construction inspection, land surveying, right-of-way, and telecommunications even. And I kind of got a lot of the asset management going probably 8-9 years ago. It became apparent to me when talking with a lot of clients that there was a lack of record keeping for roadway assets, that when you start to look at like a county, for example, and you realize that if you tally the roadway value of your county up, it can easily be, $500-600 million, that possibly you might be wanting to take better records of that. So we started looking a lot at doing asset management back then, and just creating plans that would, show costs and maps of proposed improvements, and ways to pay for that, and seeing where you were going to be at in 5 years. And we started to see improvements, especially in communities that were going into that full bore. You were starting to see improvements, especially in roads where maintenance was, I guess, key more so than others. You definitely run into issues, especially back in the early 2000s, where some roads would get more love than others. But in the end, going over that data, you could see the fact that for example, crack sealing and fog sealing a road would freeze the Pacer score for 15 years versus watching another road that didn't have anything done to it drop from, say, a 9 down to a 5 or even a 4 or less. So, and in doing that, we, are trying to then push this to another level and getting our clients, the services they need to go after grants like community crossings or highway safety improvement program grants, as well as others that seem to be popping in that we're doing research on, in order to make sure that anything that we show in the plan needs to be done can be financed, not just locally, but with the help of state or even federal funding. So when we first started doing our work around the state, we had a couple of clients that were very interested in the work. And for example, Greenwood, we ran a 20-mile pilot study. Grant did the driving there. Our biggest push was to see how well everything seemed to work, and then cross-check the data we got from the LiDAR and the AI data with what we saw on the ground. And the funny thing is there were times in which I thought it was wrong, and then I would go back through the data and then look at it in the field and realize that it was actually finding things that I didn't see in the first place. And I've been doing this for 15 years. So a lot of those things you start to get an appreciation of just how powerful the software was. For example, one of the best ways of finding rutting I found in the past was, instead of putting a straight edge down everywhere, was to just measure the width of the road with a little wheel tire, and every time it dipped in your hands, you knew you had a rut. So while an imperfect way of doing it, it was a quick and dirty way of doing that. Well, you can imagine doing that, a couple thousand times while rating your roads, and you're going to make a few mistakes in there. And the LiDAR was pretty good at catching every single one of those problems. So we've done over 1,000 miles, both in urban and rural settings now. We've discovered, issues in data collection, and have worked through those issues, especially when you're out in rural areas. Cell phone coverage, we've found redundancy helps out considerably in keeping your speed up, as well as keeping your GPS accuracy up, especially if you're going around hills. So in that aspect, we feel like we've worked a lot of the bugs out of the software in the first run. So now, how are we using it? We're definitely improving asset management. It's not just road ratings we're getting now. We're getting signs. We're even asked right now. We're looking at lighting. We've been asked to look at lighting or up to poles, utility poles, especially trying to differentiate those between city poles and county pole, or not county poles, but utility poles. So the data we're getting is much more robust, and it's improving what we can do as far as organization goes, which does help in prioritizing what you really need to look at. So, and of course, this better data gives you more avenues to go, especially when you're looking at going after funding, whether it be community crossings or HSIP or any kind of other grant. You have something that's very robust, very easy to use, very easy to prove what you have at your fingertips. GIS data works well with spreadsheets as well as other database software packages so that you can kind of output what you need in a tabular format or print it in a map format, which was you kind of saw below or before with like the red, yellow, green type of rating system. And of course, that gives you a lot more functionality as far as coming up with solutions, as far as sign replacement, maybe new posts, looking at replacing guardrail where say end treatments have been hit. We're even looking at trying to map sidewalks now, looking for ADA ramps or faults in those particular areas, as well as what roads need what kinds of treatments. If any of you have done PASER ratings, they like to talk about the right treatment for the right road. This definitely helps you with that aspect. So Huntington County, which I brought up before, is 618 miles. Could be done fairly quickly. You're driving it. Huntington County wasn't quite roadway speed, but we're still talking 30 miles per hour, plus or minus. Being how large it was and how remote some sections of it was, especially the southwest portion of Huntington County, we had cell coverage and GPS connectivity issues that we worked through the software, again, creating some redundancy and some bug fixes to make sure everything worked. And now, as we're using it in rural areas, everything seems to be going off without a hitch now. So, and again, doing quality control checks. Oddly enough, we had several roads that improved from the last time we had done the inspections. I didn't see in the historic records whether those roads had been worked on, and then come to find out that they had been chip sealed and that they were literally roads that the county had not put in the records, that we were able to slip back in the records and say, oh yeah, this road that went from a 5 to an 8 got chip sealed. So and that's the reason why it improved since the last time we did the road rating. So what I would call slippages in data collection can easily be corrected once you have that. So data-driven inventory, sign inventories, that's a big change right now to the landscape. Before, sign inventories had to be manually done. Retroreflectivity was hard to do. You needed an expensive piece of equipment, and in most cases, a ladder, which was then put up on a post, which was fairly dangerous to get your retroreflectivity reading. And of course, everything took several minutes per each sign. So you can imagine how long that took. Now you have something that you can just drive by. It picks up a picture of the sign. It gives you the location, gives you the MUTCD code, size, and we're working on basically lining up the LiDAR data or LiDAR reflectivity with retroreflectivity to get sign condition ratings. That's one of the features we're working on right now with the software. So, and then when you're working it, what we found is counties usually average about 10 signs per mile, cities and towns about 40 signs per mile. So you kind of see what you have out there. And again, you start doing the math and you realize you have millions of dollars worth of signs out there. You really need a fairly comprehensive system to keep track of all those signs. Whenever I did site inventories for the town of Avon, I think they pretty much figured out that every single sign in the city was replaced about every 7 years, given damage, vandalism, or just degradation from the weather. So it's you start to get an idea of how much effort it would take to keep track of all this. And again, your sign inventory can be completely out of date within 7 or 8 years. You want an easy to follow process to be able to update it. And of course, we found that about 8% of the signs were not linked to an MUTCD code. A lot of them were specialized signs or even small advertising signs that kind of looked like a street sign but snuck in the inventory. Once you identify those things, you could pull those out or add them in as a specialized sign. So again, we found we could save quite a bit of time. In the past, I was able to do road ratings for an entire county. It would normally take me driving hard and fast everywhere, which probably wasn't exactly the safest thing. It would easily take 100 hours to do a county. Now you can do it in a fraction of the time. Your accuracy, every one of your measurements are geolocated, whereas in the past you were literally just looking at roadway segments. The one thing this software provides is not only can you look at roadway segments, but you can break the roadway segments down in 30 and 40-foot sections, and that can give you kind of a micro analysis of your roadway network. So, and given the fact that once this data is uploaded to Cyvl.ai's cloud, you have access to this data for a long period of time, and have access to it in the future. Cyvl.ai does not make it proprietary. You can get that data via GIS back and log it in your own servers. GIS is a very powerful tool on keeping track of all this. A lot more people have become rather confident in using GIS. It's kind of a little brother to CAD in that it kind of works in some of the same ways CAD does, but it's much more powerful as a database system. And once you start to get better using it, you have easy access to historic data and current data using either GIS or Cyvl.ai's online software platform, which is also very, very user-friendly. So when, kind of doing these presentations in the past, one of the things you were trying to push was, an ounce of prevention beats a pound of cure type of advice. And, it was found, the Indiana Department of Transportation found quite a long time ago that there was about a 14-to-1 rate of return on chip and crack sealing, and possibly $6 plus on other types of roadway treatment, 6-to-1 return on investment. And so, especially when towns, cities, and counties realized that it was becoming too expensive to repave every single road every time they fell apart, it became more apparent that preventative maintenance was the future. And of course, doing that, doing a roadway ratings gives you the data necessary to do that asset management, which you can use to create a 2 or 5 year plan. And of course, that's where First Group can come in, and we can even help you start that yourselves with asset management plans in the future. After you get your roadway ratings from the Cyvl.ai software firm, you use that to create an asset management plan, which we can use to create maps, cost estimates for future improvements, as well as what we think your budget should be. And if you have a capped budget, we can tell you what your future PASER rating will be, especially as opposed to what your current one is. And that's a very good piece of evidence to have or information to have going to mayors and city councils and county commissioners, that they have actionable numbers to work off of. They know that it's going to cost $2 or $3 million of maintaining your roads in the future every year to maintain your roads. A lot of communities that I went into, I was shocked to see that they might have had $100,000 a year to work with. And I was telling them they needed, 10 to 20 times that. And a lot of the political leaders were just unaware that they were being so underfunded. So just telling that story to the political decision makers makes a huge difference in how they view roadway maintenance and then how they see this data. And of course, NDOT is pushing this, rather well with community crossings, motivating communities to take an active role in asset management. And you're starting to see a big return on investment, especially from the last tax increase. I've even seen a couple of political commercials lately that were lambasting some politicians for the last gas tax increase. And I've heard from a lot of people who were like, well, that's kind of bad because the last gas tax increase, which got us what we have today, we saw a lot of improvements in our roads since then. So when people see a return on the taxes they spend on, they're not nearly as aggravated or angry about it than something that they don't see. So telling that story not only to the mayors and commissioners and councilors, but also getting that out to the public as well makes everybody aware that what's going on is definitely something that they want to back. So next thing, one of the really cool things with this software is the 360 imagery every 30 feet. So a lot of cities and towns have Google imagery through most of the streets, but a lot of small to mid-sized towns, especially in Indiana, only have sparse coverage. And the imagery that Cyvl.ai gives you is basically as good a quality, if not better, than what Google provides on a very timely basis. So you definitely know when the street view was done, what date it was done on. I've had a couple communities reach out to me just talking about this alone. There are zoning issues that they were concerned about. They've realized that they have constituents that raise complaints on things that they can now track over time, so that they can see that the complaint was valid 2 months ago or not, or if something is really a systematic problem. So the imagery coverage is definitely a plus with the output of the software. And as you can see here, this is the town of our city of Rensselaer. Google Maps maybe got 10% of the town, and we got 100% moving forward. And it's a brand new scan, not something from 2012 or 2017. So what's this software able to do? It definitely allows us to take on larger projects. We can do, cities on a very economical basis. Cost-wise, moving forward, it's definitely very cost competitive on a city front. And on a county front, it is still comparison and cost to boots on the ground, except you get a lot more data for it. So I would say it's still more bang for the buck. And it allows you to not only get the PASA ratings, but you have LiDAR data, imagery data, and can easily add on sign data and other infrastructure, manholes, guardrail, sidewalks, other things like that. So all in all, it's just a much more cost competitive and efficient system to use than the old school method, and definitely a lot faster. So with that being said, Jeff, I don't know if you had anything to say, rounding things up.
I think you did a pretty great job there, Shawn, man. Made it sound awesome.
Well, this is definitely exciting stuff. When AI first reared its head, I had no idea how it was going to be used, especially in our field. And now we're starting to get an idea of where it's coming from.
Mm-hmm.
I'm starting to use AI and other functions as well. even writing emails, I've used AI to create kind of a base format for some types of emails. So you start to see where it's coming at you in our daily life and how you can use it to speed things up and organize it. In this respect, the AI scans several terabytes worth of data and gives you usable GIS files that are only megabytes in size, so much easier to use on a home computer. So it's just it's what I would call the first user-friendly version of computer-aided asset management I've ever seen, is the best way of putting it.
Yeah, I'd say on a very similar front there too, Shawn, because we control the hardware, we've developed this sensor stack ourselves, we're really able to get more and more out of that data as time goes on. And you've seen in the 6 months we've been working together, just the amount of new deliverables we're able to bring to projects And really, the amount of new different kind of measuring and mapping we're able to do is only going to increase over time. So it's just the best is kind of yet to come from this technology and this AI that we're developing here today.
So with that said, I don't know if anybody has any questions or anybody wanted to sit around for any additional one-on-one, if they had any ideas on how they were looking to use it going forward. We've actually had people, like I said, asking us, can it do things for, recording property assets for zoning questions and whatnot. And I'm like, well, there's an idea. So the LiDAR, as well as the mobile photography or digital photography, melded with the AI, gives you a lot of tools to use in order to pull that data out and then make it actionable. And of course, putting in GIS gives you something that you can point to and select and then read and see what you have to work with. So it's definitely a pretty cool time to be moving ahead with this kind of technology.
Hey, Shawn, it's Trevor. I got a question real quick. So Cyvl.ai sends you guys the unit that you put on your own vehicles. Is that it?
Yep. Pretty simple. They even gave us the roof racks to use for the vehicle. So,
And then you guys do all the processing yourselves of the data, or is there not much involved with that?
We're going to be doing, Cyvl's going to be doing the processing of the data. They then take those deliverables and they make their, pavement management plans or map out the different assets for their clients on their different GIS softwares and things like that.
Gotcha.
So yeah, the biggest thing is the AI is combing through all of that data to give you your output. I used LiDAR many years ago, and it was pretty unwieldy. I was told to actually look at the LiDAR and pull out the data defects from the LiDAR, and it took over 30 minutes for the file to open on my computer. And then every time I would point to rotate in order to look at it three-dimensionally, my computer would regenerate and probably take 2 or 3 minutes. So I realized I could drive down there and look at it personally faster than I could regenerate it on my computer.
Yeah, it's about 4 million points of light a second in every direction coming out of that mobile LiDAR unit. So it's a considerable amount of data that's being collected that needs to be poured through. And really, that's the strength of the AI as opposed to a human going through all that data, being able to automate all that data.
And then for Cyvl.ai's, how are the fees structured to do the work? So is there a fee for the unit, or is that rented, or how does that?
No, we don't sell the unit itself. The use of the unit is worked into the project cost.
Okay.
Overall.
So then you guys, your fee is on a per project basis. Is that how you handle it? By segments and miles, or how do you do it?
It's based on the deliverables you need for the project, and it's based on the amount of centerline miles for the project. So
Gotcha.
we don't charge on like a per sign basis. So we're
Right.
not going to say it's going to cost you $3 a sign. We're going to say it's going to cost X amount per centerline mile to do a sign inventory.
And then the typical time from like notice to proceed until a finished product is returned, what does that look like? And it's just ballpark, right?
Yeah, it varies only slightly based on project size. Once the data has been collected and successfully uploaded to us, typically takes about 4 weeks for us to do the data processing. If it's
Okay.
a couple thousand centerline miles, it might take 6 weeks, but usually 4 weeks is the general turnaround time on a project.
Okay. Thank you.
Yeah, it's the funny thing about the amount of data is you find out really quickly how fast your internet connection is.
Yeah.
So you definitely want fiber at your office. We do not, and we found out that it was just faster to take the data home with us and upload it at our home that had fiber. So fiber, gives you gigabit speed, whereas even the cable will tell you have downloadable gigabit speed, but your uploadable speed is usually only 5 to 6 megabits, and that's not fast at all. So
Yeah, we have a few customers in more of a rural setting, and they'll just ship us the hard drive back, and instead of uploading it, and it's literally just easier and faster just to overnight it to us for us to start the project.
Okay, well,
We must have done a really good job answering everyone's questions in our presentation, Shawn. That's what I'm seeing right now. Is wow, we anticipated their questions and we answered it during the presentation.
well, as I always tell people, I'm like, well, I'm trying to keep up when I'm listening to something like this, but it's definitely a lot of new stuff to take in, and then the technology is pretty exciting moving forward with this kind of work. So I've done a lot of counties in the past manually, and it's not only mentally draining, it's physically draining. So it's definitely something that doing it with a computer is makes you feel a lot better. It's like the very first time I ever used road design software as opposed to using a T-square.
Mm-hmm.
Those of you that are not old enough don't realize that that was very time consuming, and well, your accuracy was limited by the pencil or pen you were using. So I think I saw a question come up about speeds.
Yeah, I can answer that. So right now the recommended top speed is 30 miles per hour. That's just to ensure that you're going to get high quality imagery as you're driving down the roadway. Um, we are finalizing the next generation of our sensor, like version 4 of our sensor. And this next generation is going to be able to collect data at highway speeds. So we'll be able to drive 65 miles an hour down the roadways. Well, down the roadways we're allowed to drive 65 miles an hour, and do a very highly accurate data collections at those speeds. So we're pretty excited about that. That should be ready by the end of springtime this year.
Yeah, what's really interesting is if once you're able to go that speed, you'd be able to get the freeways. I know
Mm-hmm.
the funny thing I've realized with asset management on freeways, and I've not really done any, except when I was at NDOT 20 years ago, was that it's so busy. A lot of places are virtually, you can't get to unless you drop a lane and have all this maintenance of traffic set up ahead of you so that you can get traffic safely merged over to even look at it. Even at nighttime, that can be a crazy experience. So this process is a game changer on that front. There's an inlet on the inside of 465 that routinely overflows and spills onto the highway in the middle of a curve on the north side. Then every time it rains real hard, every time I come up to it, there's 2 or 3 cars spun out and on the shoulder or down in the ditch, from hydroplaning on it. And I'm like, I've tried explaining to NDOT where the location is, and I'm like, well, it's somewhere along that curve. There's a problem. So, and of course, if they're going to get out there to fix it, it's they kind of need to know where it's at,
Mm-hmm.
or else they're exposing their crews to a pretty dangerous situation for a longer period of time than they need to be. So.
We had another question coming here. Cost per center line mile just for pavement. Really, we can kind of connect with you after this if you'd like. Whether that I'm not sure, John, if you're representing a municipality or if you're another engineering firm interested in our service. But typically on a webinar, we're not going to really get too much into the cost involved, other than the fact that it's very competitively priced, I'd say.
Okay. Yeah. Yeah. Happy to link up after this and
Sure.
chat. I work for the DNR. I'm
Okay.
the civil section manager for the DNR. We have about 380 to 90 properties across the state of Indiana.
Okay.
So all your state parks, forestry, all that kind of stuff.
Mm-hmm.
Managing our pavements is a challenge. So looking at taking advantage of something like this to be better informed, make good decisions about what projects we move forward.
That'd be great.
Yeah, so just looking at pavements mostly, but yeah, I see your emails here, so I'll shoot you a note
Absolutely.
this, and we can talk more. But yeah, we're probably a couple years out developing this plan as far as how we're gonna go about it, and we think this might be an option. So thank you.
Be a great option for you. Yeah, I could see even just getting that updated 360 imagery for those areas as well is probably awesome. And then we don't have to limit the 360 imagery either, just to the roadways. We can get it on like a golf cart. Go down pathways with it, or bike paths with it as well. Or even drive it around different areas of the park if you wanted to have like updated 360 imageries of different areas of the park, around the lakes, things like that. You're not limited just to the roadway if you're talking 360 imagery. You're not really even limited to the roadway if you're talking about doing data asset collection too, like signs and things like that.
Yeah, I can see a lot of that being really helpful on the DNR side, especially if you were to have like connections with the DNR website with the 360 imagery. Like for RVers or campers or hikers or stuff like that, people are just looking for general information, what to expect in an area, how big it is, how forested it is, how tight the areas are.
Mhm.
That would be a kind of a game changer in a lot of places. You just don't see that kind of information out there. The best you can hope for is Google Maps has driven a park beforehand, and that's kind of spotty. I found so.
Okay. Yeah, we'll link up after this and talk
Absolutely.
more. Okay. Thank you.
Thank you. I got a handful of questions if you got some time.
Sure.
So quickly, our firm just bought like a mobile LiDAR unit. Does your process, or what's the workflow if we have our own unit?
Yeah. So at heart, we're a data processing company, right? A mobile LiDAR imagery data processing company. So we work with a variety of other sensor stacks out there in the market today. We do obviously provide our own sensor stack to engineering firms that need to have a sensor stack for their data collection. But if you guys have one, you want to get the most out of it, really we can pull out deliverables that you might not currently be able to based on, the software that came with it. Happy to link up with you and kind of have deeper conversations about those kind of things as well. But yeah, it's
Okay.
very common for us. I'd say about 20% of our current engineering partners, we're doing the data processing of their own sensor stack.
Okay. And then I assume it's cheaper. You get a discount if you like package like signs, pavement marking.
Yeah. So
All that.
so not to get too into the nitty gritty of the
Yeah.
pricing structure, but like the initial cost, what costs the most here, guys, is the base mapping, putting together all the different imagery and mobile LiDAR and the GPS points together to create that big base map, 3D model of the whole world of the data that you've collected. Once that base mapping is collected, the additional attributes we're pulling out come out at a much less cost. So really, it's like the first asset is your most expensive asset, and then every other asset after that is going to be relatively inexpensive. And what's good about that as well is that we can then, if you're working with a client, we scan their town and we've already done the base mapping for it. And 6 months later, they say, hey, I need to know where all my guardrails are now. I love what you guys did before. Can you tell me where my telephone poles are? Well, we've already done the base mapping. We can pull out those deliverables now at a much lower cost.
Okay. And then the last question. So if the city like already has predefined like street segments,
Yep.
like in their GIS, I assume you can just apply the ratings to whatever segments we give
you.
you.
Can map to their segments, exactly. So
Okay.
how our AI works, typically if we're talking just pavements here, it's going to automatically do 30-foot segmentation. So you get a report of every 30 foot of the roadway looks like, and then if they have segmentation in their mapping, we'll then map to the segmentation saying, okay, this whole section of Main Street's if we're talking Pazer, a 7.
Yeah. Okay, that answers it. I'm sure I have more, but I'll just schedule a meeting with you guys later. I know Emma's been hitting me up on LinkedIn, and I've been ghosting her. So sorry, Emma, I've been busy, but I'll get back to you guys.
It's funny. It's funny that you mention that because depending on what you pull from open source, different cities and towns have different segmentation. I've I've seen cities and towns have segmentation every 10 blocks. I've seen them have it segmentation every half block. Yeah, you're kind of like, okay, how do I make this work with everything? I guess that's probably most of what we're talking about. Any other questions? Now's your last chance, especially what to expect if you try to get one of these going yourself.
Great. If not, we'll see everybody at road school next year at Purdue, huh?
Yeah, Jeff is now sold on the road school concept. So
I'm putting it into my contract here at Cyvl.ai that I'm the guy that goes every year now.
okie dokie. Well, for those of you still remaining, thanks a lot for your time,
Really
and
appreciate it. Absolutely.
Emma's going to send out some information later on to everybody, but I think we got everything that we need to.
Awesome. Shawn, really appreciate everything. Thank you to everyone that attended. Looking forward to connecting down the road, guys.